Hi, welcome to the next exciting installment of everybody's favorite section. Welcome back to inverse functions. These are the practice problems in your workbook, section 5-6. We're going to be starting on page 331. Okay. So, in this section, we are trying to find the inverse of a function. Okay. Well, when we're given a table like this, all we have to do, these are XY coordinate points. Oh, I need something to write with. These are XY coordinate points. This is the point -9, -1. Well, you know the inverse of that is you switch the X and the Y, you have -1, -9. All right. And you do that for each of these points. The next one would be -4, -7, and -7, -5. You just swap your X and your Y. -10, -3, and -13, -1. These points represent the inverse of this function. So you do that with each of these. I'm not going to bore you with these. I'm sure you can handle these all on your own. You just swap the X and the Y. So the inverse would be 8-1, 6-2, 4-3, 2-4, and 0-5. You would do the same thing over here. Very unchallenging. Give us something more challenging, Miss Williamson, because this is too easy. All right. Well, this isn't any harder. Actually, they're just written in pairs, XY coordinate pairs. So you just, do the hardest thing about this is drawing this little bracket. And then you reverse the points. So then you would have 2 first and -3 second. And then you would have 8 first and -1 second. And then you would have 14 first and 1 second. And then you would have 20 first and 3 second. And then again, the hardest part of the whole thing is drawing the little bracket. That's hard enough to draw with the regular pen, much less this thing. That's all you have to do with these. Just take each point and flip the X and the Y. Change the order of them. And yeah, I'm sure you guys can do that. Let's do something interesting. Graph the inverse of each function. Now we're talking. This gets a little more interesting. Here's what I would do. I'm going to find at least 2 points on this line, 2 exact crossing points. Looks like here and here and here. Then I'm going to name those points. This is 0, -4. This would be, that's -8, so that's got to be -10, -8, -10, -8, and then this one would be 10, 0. Now, we already know to find the inverse of this, and remember the inverse of this is this line reflected over the x equals y or the y equals x line, which this line is going to go like right through here. So this other line is going to be flipped over that. This is going to be on this side, this is going to be on that side. But here's how we're going to do it. We're going to flip these points. -4, 0, -8, -10, and 0, 10. Let's watch. Let me change colors. I'll go with green. Okay. -4, 0 is right here. -8, -10 is here. And 0, 10 is here. So when we draw this line, wish me luck, you can see that indeed this line is the reflection of this line over the y equals x line. Pretty cool, right? I thought so. I knew you were going to like this one. All right, so we do the same thing here. Your y-intercept is usually a good point for you there. There's the y-intercept. And this looks like an exact crossing point. And that would mean this also is an exact crossing point. So let's name these points. This would be -4. This would be -6. -6, +8. This would be 0, 6. The only way to really screw this up is to just accidentally come up with the wrong coordinates or something. 6, 4. Or to graph something wrong. 8, negative 6. Now I'm switching them to find the inverse function. And let me go ahead and draw my y equals x line. You don't have to draw the y equals x line. I like to do it because it tells me that I've done it right. If I draw that y equals x line and then my new line looks like it's been reflected over it, I feel pretty good about my new line. Okay. 8, negative 6, so this would be 8, and then negative 6 would go down to here. 6, 0 would be here. And is that 4, 6? 4, 1, 4, 6 would be here. All right, so this line goes... Does it look like it got reflected over y equals x? Heck yes, it does. Okay, so that's basically what you would do. This one could reflect oddly because it's kind of like all over here on this side. And if I think about the y equals x line, I guess it's probably going to go like here, like that. Yeah, it would be like that. All right, I'm not going to do all of them. That's pretty straightforward. I think you guys can do that without any further examples. Let's get to the more. Oh, here we have more examples. Oh, maybe we'll do 1 or 2 of these just for fun. Which one do you want to do? Lucky number 13? Let's do lucky number 13. All right, we got a point here. Is that a point? That looks like a point. That looks like a point. And that looks like a point. I won't do all of those. This is 0, 3. This is 1, 1. What's going to happen when we flip 1, 1, right? This is 2, negative 1. All right, that's good enough. And so then we'll have 3, 0. We flip them. 1, 1 is 1, 1. We know we have a point of intersection there. And 2, negative 1 is negative 1, 2. So 3, 0 would be here. 1, 1 is here. And negative 1, 2 is here. Oh boy. Oh boy. Not bad. Here's my y equals x line. And so basically this point is over here and this part is over here now. Pretty cool. All right, so I think you guys can do those. Just find a couple of points, flip them, graph a new line. Now here's where it gets interesting. These are the ones where you remember it. First thing you do is you get rid of the f of x and you make it y. Time to go to 7th period. Like so. Then the second step is you switch your x and your y variables. So we make this x and we make this y. Then you solve for y again to get it back into slope-intercept form. Okay. Let's see. I'm going to add 5 to both sides. That gives me x plus 5 equals 8y. I'm going to flip this to get the y on the left-hand side. You can do that as long as you flip everything on each side. Okay. And now all I have to do is divide everything by 8. These cancel, and I get y equals x plus 5 over 8. And this is an acceptable format in this section. You could write this in a better format. If you wanted to write this in a slope-intercept form, then you could go a step further, and this would be y equals 1/8 x plus 5 over 8. This is also acceptable. Both of these are equal to each other. Ooh, look at number 17. Well, what do we have here? Let's change the f of x to a y, and let's distribute. Now we have 6x plus 42. Now it's boring. Now it looks just like the first one. All right. We got to swap out our x and our y. It's 42. We got to subtract 42 from both sides. Gives me x minus 42 equals 6y. I'm going to do the swaparoo. 6y equals x minus 42. And then you would divide both sides by 6. And it gives me y equals, technically this is 1/6 x minus 7. You know what? Hang on just a second. I'm going to go over to the reveal assignment and look to see what format they will accept as a correct answer for these. And that's important information. It'll just be a flash for you, but I'm going to go put you on pause and I'm going to go check that. I'm back. Okay, I looked at the answer key. Here's what these are. These are going to be multiple choice, okay? But looking at the answer key did remind me that I'm failing to make the last step in each of these. And you'll remember the last step is that you have to write this really weird looking f to the -1 of x. You got to get rid of that y again. And then the format of the multiple choice answers is this kind of a format right here. They have not taken the extra step to go to slope intercept form. They left it like this, okay? But what you're going to be looking for is f to the -1 of x. So here, to be perfectly correct, I should have gotten rid of that y then and did f to the -1 of x equals, and this would have just been x minus 42 over 6. Is how it would look in the multiple choice solutions. Okay, glad I looked. You never know with reveal. I tell you one thing and then their answer key tells you something totally different. Try to do that with that. There we go. Okay. So I think this is worth doing one more of these. Maybe I'll change color so it doesn't run into the other example. Okay, we take the f of x out and we replace it with y. 3/4 x plus 9. We swap x and y. X equals 3/4 y plus 9. Subtract 9 from both sides. Gives me x minus 9 equals 3/4 y. All right, now in order to get y by itself, well, I could do the flipperoo here. Let's do the flipperoo. 3/4 y equals x minus 9. To get rid of this, I need to divide both sides by 3/4, or I can multiply both sides by 4/3, which is the same thing as dividing by 3/4. But here's what this is going to look like, right? So these are going to cancel out. What this will look like in the answer document, I didn't get this far, but this is really how I would write it. It's unlikely that they will distribute it knowing that they have done this on the other problems, but I'm sure that you all are perfectly capable of distributing 4/3 and getting an alternative answer. Oh, and look at me being all fancy. F to the -1 of x. Fancy. Yes. So it would be one of these two forms, and you know these are both equal to each other. Not telling you anything you know. Just destroyed that. Okay, moving on. Okay, now some of these are getting a little more interesting. Ooh, which one do you want to try? I don't want to make this video too long. I'm already at 14 minutes. Let's go for number 21. Yeah, let's do number 21. This will be super fun. Because actually number 19 is a no challenge problem there. There's not much challenge to that one. We've already done ones like that. But this one's different. Okay, so same first step. We get rid of the f of x and we replace it with y. -4x plus 1 divided by 5. And then we switch the x and the y. So we have x equals -4y plus 1 divided by 5. Okay, first step, we can't do anything with this numerator until we get rid of this fraction thingy. So let's multiply both sides by 5. That gets rid of that. Now I have 5x equals -4y plus 1. I still want to get 4y by itself, so I subtract 1 from both sides. That gives me 5x minus 1 equals negative 4y. Then I divide both sides by negative 4 to get y by itself. I'm going to do the switcheroo over here. Y is then equal to 5x minus 1 over negative 4. And then I have to get rid of the y and make it the f to the negative 1x. Makes it really look scary. If your younger brothers and sisters see you doing this, they're going to be terrified. So I'm telling you. Negative 4. So that would be like the format that you would be looking for in your multiple choice answers. Okay, so right away we go to word problems. All right, so that means that the f of x is kind of out the window now, and they've replaced it with p of x. But you remember in the last video, I explained to you that it doesn't really matter what this letter is. It's just we use different letters when we have different functions and we want to somehow label them, you know, or maybe we're working with two functions. We want to be able to identify one from the other. We change that front letter. We just tend to start with f because we call them functions, and the word function starts with an F. Bernardo spent $15 on supplies for his lemonade stand. He charges $1.25 per glass. The function right here represents his profit, where X is the number of glasses of lemonade sold. They want you to find the inverse. So we have P of X equals 1.25 X minus 15. All right, replace this with Y. I hate decimals. I ever told you I hate decimals? I'm not a fan of decimals. I can do fractions in my head usually, but decimals, never. I just can't keep the decimal places straight. I always have to use a calculator. Okay, so I replaced this with y, and then I swapped out x and y, just like we did before. Now I'm going to add 15 to both sides. That gives me x plus 15 equals 1.25y. Okay. Now we're going to divide both sides by 1.25. All right. Those will cancel. And the end result would be f to the negative 1 of x. Now let me just look at this one in the book and make sure, because I don't like having a decimal in my denominator, but I don't know if they're cool with that. Yeah, they're cool with it. So yeah, we're going to just leave it there. Equals x plus 15 over 1.25. Well, when I went to school, we were told never have a decimal in your fraction, but apparently Reveal and I did not go to the same school. Okay, so the inverse function, you know, it's f to the negative 1 of x equals x plus 15 over 1.25. Okay. What do x and p, what did the p to the negative 1 of x represent in the context of the inverse function? Okay, so in the original problem, he spent $15 on supplies, but he charges $1.25 per glass. So the $1.25 represents his profit, okay? This is the amount he's starting out kind of in the hole, so to speak. He already spent $15. So this equation here will tell us, after he's sold so many glasses, how much he's in the black or the red, okay? Accounting terms. When you're in the black, you're in the positive. So once he's made more than $15, he would be in the black, according to accounting terms. All right, so this is how much total money he has, and the X is how many glasses of lemonade he sells, okay? Well, when we switch it, what does it represent? Well, remember, when we do an inverse function, we're solving for something else. So this P of X is no longer going to be how much. Let me check and see how this one looks. Hold on a second. Okay, this looks like drop-down boxes, so you're not going to have to explain this. Okay, when you reverse these things, you reverse them. Okay, so if P of X was his profit, and X was the number of glasses. Now, X is the profit, and P to the negative 1, I did that badly. P to the negative 1 of x is the number. This switch, just like you would switch an xy point. If this was profit before, now it's the number of glasses. If this was the number of glasses before, now it's profit. Okay. How many glasses must Bernardo sell in order to make $10 in profit? Okay, well, we want him to make $10 in profit. So which form of the equation is best for us? It's best to use the inverse function for that. Because, and I'll tell you why, f to the negative 1 of x, well, and this would be of 10, okay, equals x10. That's where I'm going to put the 10. You replace x with your 10, 125. And we could have used the other, no, we couldn't use the other function. We would have had to put the $10 in profit would have to be this symbol. We'd had to put the $10 on this side, and then we would have had to solve for the variable on this side, the x. In this one, we're putting x in for 10 and solving for that one. I probably just confused the heck out of you guys. I'll do more examples. I'll do it better next time. So that gives me 25 over 125, which I have my handy dandy calculator, which I always need on decimals because I stink at decimals. 25 divided by 1.25. I know you've probably all got the answer by now. Bunch of smart kids. 20. So in order for him, how many glasses must he sell in order to make $10 in profit? He must sell 20 glasses. Pretty fun. I think we need another word problem. Look at that. Huh. There we have another word problem. Ask and ye shall receive, right? Alicia started a baking business. She spent $36 initially on supplies and can make 5 dozen brownies for $12. She charges her customers $10 per dozen brownies. The function P of x equals 7.6x minus 36 represents her profit, where x is the number of brownies sold. Okay, so we're going to do this in a very organized fashion. First of all, the original equation is P of x equals 7.6, more decimals, x minus 36. And they're telling us that P of x is profit, and x is the number of dozens of brownies. Equals the dozens of brownies. So we know, once we find the inverse of this, x will be the profit then, and p to the negative 1 of x will be dozens of brownies, okay? Find the inverse function. You saw that coming, right? They're gonna, okay, so we have y. We replace it with y. That's all we do in the first step. I'm probably driving you nuts because I refuse to do 2 steps at once. Switch them. Okay. Solve for y. Add 36 to both sides. Gives me x plus 36 equals 7.6y. And then we divide both sides by 7.6. Those cancel. Now I'm going to do the great flipperoo. That gives me y equals x plus 36 over 7.6. So my inverse, p to the negative 1 of x, got to be all official, equals x plus 36 over 7.6. So that's the inverse function. What do x and p to the 1 of x represent in the context of the inverse function? Well, originally, x was dozens of brownies, but now x is profit. They switch. And p to the negative 1 of x is now dozens of brownies. Inverse. How many dozens of brownies does Alicia need in order to sell in order to make a profit? Ooh, so we just want to make a profit. They want to be in the black, so to speak. So how much can she sell to compensate for the $36 she spent initially? Okay. So at that point, what we really want, don't we want profit to be 0? That's a plan, right? We can make profit be 0, and that would represent the exact moment where she has recouped the money she spent, but she hasn't made a profit yet, okay? So I think that's what I'm going to do. I'm going to say profit is 0, okay? So we're going to have P to the negative 1 of 0, so I'm making X be 0, equals X plus 36. Oh, wait, I forgot I'm supposed to substitute 0 for X. 0 plus 36 over 7.6. Well, 0 plus 36 is 36. Divided by 7.6, and I'm going to whip out my calculator because I can't do that in my head either. 36 divided by 7.6 is, whew, that's one of the more rational things, I think. It's taking up the whole, all right. So we've got 4.7. I don't think she wants to sell 4.7 dozens of brownies, because probably wants to sell whole dozen. So she's going to have to sell. When she sells 4, she's still going to be in the red. And then when she sells that 5th dozen, she'll be in the black. Let me check and see how they wrote it. Make sure I'm not telling you wrong. They said 5, so that's what we were saying. 4 is not going to put her into a profit margin. And 4.7 makes no sense because she's not going to sell 7/10 of, hold on to that thought. I'm sorry. I get interrupted again. Oh boy. Okay. I'm getting mad now because I really like this section. They're starting to tick me off. Okay, so that was our answer 5. Moving on. Okay, so here we have more word problems, and I don't want my video to be over 30 minutes, so I'm going to kind of just talk through how I would do this one. You have your function right here. You would change this to y, swap y and x, find the inverse function, and then they want to know what x and c to the negative 1 of x represent. So, of course, you would say originally they meant this, and now they mean the opposite. And then you solve with your new inverse equation for when x is $470. Okay, do it just like we did before. Same thing here. Same. Okay, maybe I'll do these in class. All right, this one I thought was kind of interesting. This one is an application. The area of the base of a cylindrical water tank is 12 pi square feet. The volume of water in the tank is dependent on the height of the water h and is represented by the function v of h equals 12 pi h. So find v to the negative 1 of h. What will be the height of the water when the volume reaches 420 pi cubic feet? All right, this one's going to take some time. But I can go ahead and find the inverse of this. So if we started with v of h equals 12 pi h, and they're making this tricky because they're throwing pi in here instead of just giving you a number, okay? So I would go ahead and I would change this. This one, I would normally make it y, and I don't see any reason to not do that at this point. We just need it to be a variable, right? So 12 pi, and h is our other variable. Then we switch these. So we would have h equals 12 pi y. That rhymes. And now we need to get y by itself. So we just divide both sides by 12 pi to get rid of that. And so we have y equals h over 12 pi. All right. And then we would take the y out, and we would say v to the negative 1 of h equals h over 12 pi, right? And then you would take the 420 pi, and you would put it here in the h, all right? And watch what happens when you do that. If you put 420 pi over 12 pi, what cancels there? The pi's do. Okay, then you just do the 420 minus or divided by 12, and you will have your answer. Here's where I wanted to get. Okay, this will be my last example for this video, and I will do several of these in class, and I'll do them on both days so everyone gets to see them. Write an equation for the inverse function that satisfies the given conditions. Okay, this one has the slope of f of x is 7. Graph of f to the negative 1x contains the point 13, 1. Okay. Oh, hold on again. I fear my video is doomed. Okay, so where were we? All right, we're starting on number 1, or number 33 anyway. Number 33, the things we know. We know that the original equation, f of x, has a slope of 7. But that's all we know about it, or is it? We also know that f of negative 1x has a point 13, 1. Can we use this to find a point on this one? Yes, we can. We know this one would have a point of 113. All right? Well, if we have a point and a slope, can't we write an equation? We can write an equation in slope-intercept form too, can't we? Because we would do y equals mx plus b. So we have y, I'll write it, equal, I'm not going to get lazy on you. I know it's late on a Friday, but I'll do it. We have y equals 7x plus b plus 1. Oh, no, dang it, I keep getting distracted because people bugging me. Now I make a mistake. Darn it. I need to put a number in there for x. 13 is my y. My slope is 7. My x is 1. And the b is the thing I don't know. Finally. Idiots. 7 plus b, subtract 7 from both sides, and I get b is 6. So now I know the equation of the original is 7x plus 6. That's the original equation. But they want the inverse, okay? So that means that I'm going to write it y equals 7x plus 6. I'm going to swap x and y. X equals 7y plus 6. And then I subtract 6 from both sides. Gives me x minus 6 equals 7y. And then I divide both sides by 7. And I get that f to the negative 1 of x is equal to x minus 6 over 7. Yep. There we go. For number 34, they're giving you 2 points. So what can you do with 2 points? You can find slope. Once you have slope, if you have slope in 1 point, you can do the y equals mx plus b thing and find the y-intercept. All right? From there, you can then go ahead and write the equation in slope-intercept form and then find the inverse of it. But I'm going to have to save these to do in class or maybe a new video. I'll just do them in class. And we'll have a lot of fun with these. And this video is already over 30 minutes, and I'm not going to bore you any longer. Hop on over to McGraw-Hill. There is a practice waiting for you. I'm sure you're going to do great. Have fun finding inverses.